Hi everyone, so I come back with the revision part B. The one I did was part A, and most of you have been requesting for me to finish up all the questions in your quiz. So the first question was saying, let star be a binary operation on Z defined by x star y being equal to x plus y minus xy plus 2. The first question is telling us to evaluate negative 3 star 2 star 5 star 4. So this one is simple and straightforward. What you just need to do is first to work out whatever that is in the brackets. You always don't have to forget that mathematics is the same wherever you are, in whatever program you are doing, in everything. In short, mathematics is the same. So here we also have to follow BODMAS, meaning we start with whatsoever that is in the brackets. So what we do is to find negative 3 star 2, you just replace negative 3 where there is x there, where there is y you put 2, again you go to the other brackets, where there is x you put that, where there is y you put that. So in other words, what I'm trying to say is this. So let me just copy the question. Yes, like this. So what I'll start first by dealing with this part, and then I'll come to this other part. So where there is x in this where there's x in this expression, I'll put negative 3. So this is going to be negative 3 plus y, which is 2, and then we have negative xy. We put negative 3 times 2, and then we put this in square brackets. Same applies to this other part. You do the same. Where there's x you put 5, then where there's y you put 4. Say minus, we have 5 times 4, and then sorry, I've forgotten something here. There's supposed to be a plus 2 outside. Then you close the brackets like that. Then from there you also do the same this side. After multiplying there is a plus 2 this side, and then you close the brackets. So from there what you do is you just have to simplify whatsoever that is in the brackets. So when you add this negative 3 and 2 there, you get negative 1. So negative 1, you have 3 times 2, 6, times that negative, you get positive 6, and then plus 2, so you are getting something like positive 8. Let me just go through. This will give you negative 1, 6 plus 8 plus 2, 8. Okay, so when you add negative 1 plus 8, you simply get negative 1 plus 8, you get 7. So you're going to have 7 star. We also deal with whatsoever that is this side. So we're going to have 5, this is 20 here, 5 plus 4 will give us 9, minus 20 will give us negative 11, plus 2 will give us negative, is it negative 9? Yes, something like this. So what we are just remaining with is just putting where there is x we put 7, where there is y we put negative 9. So where there is x we put 7, where there is y we put negative 9. So we have something like this: 7 times negative 9, then we have minus, plus 2. So 7 minus 9 will give us negative 2. Then this will be positive 7 times 9. This will give us, so this will give us 63 plus 2. So this negative 2 and this 2, you can see that they are giving you a 0, meaning our final answer will just be 63. So this is basically how you solve such a question. This is how you solve such a question. It's simple and straightforward. Okay, so we move on to the other question. The other question is saying, is star associative? So for this question you can use two formulas. Yes, you can use two formulas. So you can either use numbers to prove that star is associative or not, or use letters. So I'll give you an example of how you can use letters, and then I'm going to use numbers. If possible, I'm just going to use letters. Okay, so we say let A star B, say let A star B A star B star C be equal to, the values x, y, and you can either use A star B star C or x, y, and z, but since we are using x, y this side, at least it's better for us to use A and A, B, and C. So you first make an you first give them this expression, just to tell them to say this is what you're going to be using. So for associative, A star B star C is always supposed to be equal to A star B star C. So this is always what it's supposed to give you. And then from there, what you now need to do is to just work out this part and this other part. So you can either work them separately or just at the same time. So let us try to work them separately. If the space is going to be enough for us, then we'll do them separately. If the space is going to be enough for us, we'll do them at the same time. So we start first with A star B. So A star B, when we replace it in this expression, we'll have A plus B minus A times B, and then plus 2. So we're going to have something like this. Then we say star C, which is equal to, so if you're using numbers, you can, instead of using A, B, and C, you can just pick any three numbers. If you find that the answer that you get this side is the same answer that you get this other side as well, just not to say it's associative. But if you get different answers, then there's a problem there, it's not associative. Okay, so I'm trying to use letters here, such that letters they have long solutions. Numbers, at least the solutions are short. So we write our A this side, and then we say star. Then B star C is going to be B star C is going to be B plus C, B plus C minus BC plus 2. So here what we're going to do now is, while there is A, we're going to put this, and then where there is B, we'll be putting C. So start first by writing A. So my A is A plus B minus AB plus 2, then we say plus. So where there's A, I'm putting this, then where there's B, I'm putting C. Where there's Y, I'm putting C. Where there's X, I'm putting this. Where there's Y, I'm putting this. So we have minus, where there's X, I'll repeat that, A plus B minus AB, then plus 2. Then my Y is simply just C, and then we say is equal to, you also do the same on, oh sorry, before I do that, there is a plus 2 at the end, plus 2. So even this side you do the same. While there's A, while there's X, I'm going to be putting A. While there's Y, I'll be putting this. So while there's Y, I'm putting B plus C minus BC minus BC, and then minus BC, maybe just put them in brackets, plus 2, and then I say minus A, I'm multiplying it with all that, which is B plus C minus B C plus 2. Then apart from that, we also have a plus 2 at the end, like that. So here what is just remaining is simplifying. So when you simplify this part, you do the multiplication here, and then you pair the like terms, you do everything. You find, when you find the same answer as this other part, then you can conclude to say star is associative. So here it's just a matter of simplifying. No one can fail to simplify this. You can just say this, you pair the like terms. In short, first you simplify, after simplifying you pair the like terms. Then you find, if you find that whatever that you are going to find this side is whatever is the same thing that is going to be this side, then star is associative. Then star is associative. But if you discover that they are not equal, then it's not. So the other formula I said is using numbers. You can say let, or if not let, you just say you just say try, maybe you say 1 star 3, you get 3 different numbers, 1 star 3 star, maybe star 5. You just get 3 different numbers. Sorry, it's supposed to be like this. Okay, so I'm going to try 1 star 3 star 5. Then you say again 1 star 3 star 5. So you test these numbers. If whatever that you get this side is equal to what you are going to find this side, then conclude to say star is associative. But if they are different, then star is not associative, according to this operation. So this is basically how you solve such a question. If you've been given such a question, this is how you solve it. We move on to 3. So 3 is saying that Z has an identity with respect to star. So for identity, what you need to know is that for identities, A star, this E, so this E is simply an identity. This one should give you A, and then at the same time this A is also equal to E star A. So this is what we normally do when you're solving for identities. For an identity, what's this? Yeah, if you are solving for an identity, this is what you do. Or if you have been told to find an identity. Okay, so we quickly move on to testing this now. Does it have an identity? So you find a star e from this expression. So we're going to find the a star e. So we're going to say a plus e, a plus e, then minus a e, minus ae, then plus 2. Then this is equal to this a here. Okay, so what you do now from here, you just pair the like terms. So as you can see, you can agree with me that this and that a will simply cancel. When you take this a to the other side of the equal sign, you are going to have a 0 this side. So just remain with something like this e, then you factorize that, meaning you are going to have 1 minus a, and then plus 2 being equal to, this is a 0, so these two will go to the other side of the equal sign, meaning you just remain with e, and then you have 1 minus a being equal to negative 2. So here you just make e the subject of the formula. So this is going to be e over 1 minus a. So this is what has given us to be an identity. Now if you want to prove if this is correct, if whether what you've been given is an identity, has an identity or not, what you should do is you test this. Yeah, because what I know about identities is that if you are adding maybe any number, let's say you are adding a plus, if you are adding a plus an identity, a plus any identity, I'll call it I. Okay, let me just call it e, the one that were used to. So e, so a plus e should always give you e. That is what we mean by identities. If we say a times e, we still have to get a. So an identity does not actually change anything to the expression. So when you add an identity there, is it going to give you a? So try to find try to find a star this using this expression. If you get the answer to be a, then just know to say the expression has an identity. If you don't get the answer to be a, just a, then know to say it has no identity. So that's how basically you test for identity. Okay, let's quickly move on to the next question. The next question is telling us to say let a and b be two non-empty disjoint sets. So by non-empty, meaning these sets are not empty, and then disjoint, meaning they have no intersection. So what they are trying to talk about is this: they are talking about two sets which have no intersection, and then apart from these sets not having the intersection, they have elements there. We have elements inside, though they do not intersect. So I'll put those minuses there. Here I'll put the pluses to show that there is nothing common between the two sets. So we have a and b there, and then the question is saying express the set a complement union b complement in its simplest form. So how do you do that? You use what we call De Morgan's rule. So De Morgan's rule states that if you are changing this, if you are trying to factor out the complement, what you are going to have is if you factor out the complement there, the sign in between will change, and then after changing the sign, the complement there will be outside the brackets. Then from there you can see that we have A intersection B inside the brackets there. But according to the statement here, it's telling us to say these sets have no intersection. They are disjoint sets, meaning they have no intersection. So meaning the intersection set there is simply an empty set. So an empty set complement, we all know to say it gives us it gives us the universal set, which is this. Okay, so you can either write E or U, there's no problem. Okay, so we quickly move on to the next question. So the other question is telling us to say express this in the form P plus Q root 3, where P and Q are real numbers, hence state the values of P and Q. So for you to solve this question, it's also simple and straightforward. You just need to know what is called a conjugate. So you find a conjugate for these numbers. So the conjugate is simply just found by changing the sign that is between the given expressions on the denominator. So we have 1 plus root 3. So the conjugate is going to be 1 minus the root of 3. Same applies to the top part. It's going to be 1 minus the root of 3. But remember, when you divide these two, you just get a 1. 1 times this, which is just going to give you this, meaning what we have done here, we have not added anything to the question. The question is just the same. So we have not changed anything to the question. So when you multiply the top part there, we're going to have root 3 times 1, you get the root of 3. Root 3 times the root of times negative root 3, you get negative 3. And then negative 1. Okay, negative 1 times 1 there, you get negative 1. And then negative 1 times negative root 3, you get positive the root of 3. Yes, positive the root of 3. Let me just check this. Root 3, negative 3, negative 1, positive root 3. Okay. So the denominator there, since when you look at the denominator there, when you multiply this and that, this is just the difference of two squares. So if it's the difference of two squares, it's just telling us to say to be 1 squared and then minus the root of 3 squared. So from there, what you are going to have now is you add the root of 3 times the root of 3, the root of 3 plus the root of 3, you get 2 root 3, and then this one will give you negative 4. Then from there, you are going to have 1 squared will give you 1, then minus the root of 3 squared will give you 3. So when you simplify this, you are just going to get 2 root 3 minus 4, then everything divided by negative 2. So this is just going to be equal to 2. This negative 2 into negative 4, you get positive 2. Negative 2 into negative 2 root 3, you get negative root 3. So now we have not yet finished the question. Yes, we have simplified it to that form, but the question is also going further to tell us to find the values of P and Q, meaning the value of P is simply just 2, and then the value of Q will just be negative 1. So this is the solution to this question. Let's quickly move on to the next question. So the next question is saying the height of a projectile fired vertically into the air, neglecting air resistance at an initial velocity of 96 meters per second, is a function of x, and is given by the equation that how many hours taken from the projectile to reach its to reach its maximized point, and hence or otherwise determine the highest point reached by the projectile. So whenever you just hear maximum or anything, maximum or minimum, just know to say at maximum. Let me just give you this more expression. At maximum, this is what you need to know. At maximum, you know to say x is found by finding negative b over 2a from the given quadratic equation. At maximum, x is found by finding negative b over 2a. So at maximum, x is equal to negative, what is my b there? My b is just the coefficient of x, which is 96 over 2a. So my 2a, my a there is the coefficient of x squared, which is giving me 16. So this is it's negative 16. So this is just going to give you something like, let me just write it down. So this will give you something like negative 96 over negative 32. So the value of x is now just going to be equal to, when you divide 32 into 96, it's just about 3 times. It goes there about 3 times. So it's only 3 seconds. So it took 3 seconds. Then the question is telling us to say how many hours. So meaning to find the number of hours, you divide this by 60. Or these are seconds. So meaning you're not going to divide this by 60, but you divide it by, is it 3600? Something like that, to find these seconds in hours. Okay. Here we've been told to find them in hours. If the question was telling us to leave it in seconds, would have left it as a 3. So now the question goes further to tell us to say and hence or otherwise determine the highest point reached. So the highest point is just found by finding f of this same 3 seconds. To find f of 3 seconds. So functions are very important. You don't have to skip functions. If you think they are difficult, just go and revise them. So you find f of 3, which is just going to be 96. While there's, we put 3 there, then we say 16 3 squared. Then we find the highest point there. So 96 times 3 gives you 288. So you get 288, then minus 3 squared gives you 9. So 9 times 16 will give you 144. So 288 minus 144, you are getting 144 again. So the highest point that was reached was 144 meters. So thank you very much for watching part B of the revision of the quiz. Watch out for part C.